Absorption. The phenomena of concentration of molecules of a gas or liquid at a solid surface is called adsorption. The adsorption of a gas on a solid is sometimes called occultation. Adsorbate. The substance which is held on the surface of the solid is called the absorbate. Adsorbate. The solid that takes up a gas or a solute for the solution is called the adsorbate. Absorption. It is a process in which a substance is uniformly distributed throughout the body of the solid or liquid. Sorption. The process in which both adsorption and absorption takes place simultaneously is called desorption. The process of removing an adsorbate substance from a surface on which it is adsorbed is called deadsorption in action. If a gas like O2, H2, CO, Cl2, NH3 or SO2 is taken in a closed vessel containing powdered charcoal, it is observed that the pressure of the gas in the vessel decreases. The gas molecules concentrate at the surface of the charcoal. Gases are absorbed at the surface. In a solution of an organic dye, say methylene blue, when animal charcoal is added and the solution is well shaken, it is observed that the filtrate turns colorless. The molecules of the dye those accumulate the surface of charcoal and get absorbed. Aqueous solution of a raw sugar when passes over beds of charcoal becomes colorless as the coloring substance are absorbed by the charcoal. The air becomes dry in the presence of silica gel because the water molecules get absorbed on the surface of the gel. It is clear from the above examples that solid surface can hold the gas or liquid molecules by virtue of absorption. Difference between adsorption and absorption. Absorption is a surface phenomena. Absorption is a bulk phenomena. Adsorption is a rapid force process. Absorption is a slow process. Adsorption equilibrium is attained equally. Absorption equilibrium is attained slowly, step by step. Absorption that concentration of molecules are more one on the surface and less in the bulk. Absorption distribution is uniformly. Types or classifications of absorption. Adsorption is classified into two types: physical absorption and chemical absorption. Physical absorption. Physical absorption is the one in which the adsorbed molecules are held on the surface of the adsorbent by weak physical or van der Waals forces of attraction. For example, adsorption of H2 or O2 on charcoal. Chemical absorption. Chemical absorption is one in which the absorbed molecules are held on the surface of the adsorbent by chemical bonds, covalent bonds or ionic bonds. For example, adsorption of O2 on Ni. Difference between physiosorption and semi-sorption. First we are going to physiosorption. It is caused by intermolecular weak van der Waals forces. Absorption is completely reversible and absorption decreases with increase in temperature. Multi-layer absorption occurs. The rate of absorption increases with increase of pressure and concentration. It is not specific in nature. It involves very small activation energy. Semi-sorption. It is caused by strong chemical bond formation. Absorption is irreversible. Absorption increases with temperature. Only monolayer absorption occurs. The rate of absorption decreases with increase of pressure and concentration. It is highly specific in nature. It involves applicable activation and characteristics of adsorption. Adsorption is always accompanied by evolution of heat. Adsorption on surface of a solid is always spontaneous. Adsorption is accompanied both by decreases in enthalpy and entropy of the system. Adsorption is a selective process. The rate of adsorption depends on temperature. Adsorption is specific. It depends on the nature of adsorbent and adsorbate. Adsorption is a physical phenomenon but accompanied by a chemical change. Adsorptions of gases on solids. All solids absorb gases to some measurable extent. The magnitude of adsorption of gases by solids depends on the following factors: nature and surface or of area of the adsorbents, nature of the gases, enthalpy of reversible character of the adsorbed, pressure of the gas, temperature of the gases, thickness of the adsorbed layer of gas, activation of the absorbent. Factors influencing absorption of gases on solids: nature and surface area of the adsorbents. The extent of adsorption depends on the surface area. Those greater the surface area, greater in the absorption. A larger pore on the absorbent, larger in the absorption. This is because pores permit the diffusion of gases. For example, charcoal and silica gel. Nature of gases. The amount of gases absorbed by a solid depends on the nature of gases. Easily liquefied gases like HCl, NH3, Cl2, SO2, etc. are absorbed more easily than the permitted gases like H2, N2, O2, etc. This is due to the following reasons. Critical temperature. The EC of liquefaction depends on its critical temperature. Thus, of the critical temperature of the gases is more, it will be liquefied and absorbed more readily. For example, absorption of various gases on 1 gram activated charcoal. Critical temperature of SO2 is 430, NH2 is 406, CO2 is 304, N2 is 126, H2 is 33. Amount of gases absorbed in ml. SO2 380, NH2 180, CO2 48, N2 8.0, H2 4.5. Van der Waals forces. Easily liquefied gases possess greater van der Waals forces that permit gases, so they are absorbed more readily. Enthalpy of absorption. Heat of absorption is defined as the energy liberated when 1 gram mole of gas is absorbed on the solid surface. In physical absorption, the attraction between gas molecules and solid surfaces are due to relatively weak van der Waals forces. The heat of absorption is small, about 5 kilocalorie per mole. In chemical absorption, the attractive force are due to the formation of chemical bonds. The heat of the absorption is large, about 100 kilocalorie per mole. Reversible characters of absorbed gases. Physical absorption is a reversible process. Gases to solid plus heat. Chemical absorption is not a reversible process because a surface compound is formed. Pressure of gas. Since dynamic equilibrium exists between the absorbed gas and the gas is contact with the solid, increases of pressure increases absorption and decreases of pressure cause disruption. Temperature of gas. Physical absorption. It occurs rapidly at lower temperature and decreases with increases in temperature. Chemical absorption. It increases with increases in temperature and then decreases thickness of absorbed layer of gas. Langmuir showed that at lower pressure the physically absorbed gas forms one molecule thick layer. About a certain pressure, multi-molecular thick layer is formed. In semi-sorption, the absorbed gas is one molecule thick, hence chemical combination takes place with the absorbent surface directly. Activation of absorbent. Activation leads to increase in the surface area of the absorbent. This is achieved by the following ways. Creation of rough surface by mechanical rubbing of the solid absorbents, by subjecting to small chemical reactions on the solid absorbent, increasing effective area of the surface, by subdividing the solid absorbent into finer particles, by heating of solid absorbent is superheated steam. Now its pore was opened and absorbent